Good morning to all you folks on the other side of the world, and a good evening to everyone joining us from our part of the world. Welcome to Migrating to Microservices, Hacks to Follow and Pitfalls to Avoid, which is part 3 of our Microservices webinar series, a CXO's Paradigm to Microservices Migration. I'm your host for the evening. My name is Anusha Natarajan, and I work as an Assistant Marketing Manager here at Aspire Systems. Before we continue on with our webinar, I would like to take a moment to introduce our speakers for the day. I have here with me two of our very esteemed colleagues, Jyoti Rangarajan and Chandramouli Parasuraman. Welcome, guys. Jyoti Rangarajan is a principal architect here at Aspire and has architected over 50 SaaS solutions in various industries. She provides strategic and technical direction, helping customers move up the value chain by delivering scalable, out-of-the-box SaaS solutions. Joining her is Chandramouli Parasuraman. Chandramouli is a technical architect at Aspire Systems, focusing mainly on open source, cloud, and mobile technologies. With over 18 years of experience in the IT industry, he has worked in every role that covers the product development lifecycle. So before we begin, I would like to talk for a quick minute regarding the task at hand today. So there are a number of pitfalls that can occur if a company is not careful while trying to migrate to microservices. You can find a lot of information online about what can go wrong while migrating to microservices, but not a lot of solutions. If this sounds familiar, this webinar is for you. So keep listening as we spill the secrets to successful microservices migration while avoiding common and uncommon pitfalls. Over to you, Jyoti.
Thanks, Isha. As mentioned, when organizations make a move from monolithic to microservices, they tend to concentrate more on technical aspects and often miss out on the process and execution approaches that are very essential for altering and optimizing in a microservices world. If microservices is executed a wrong way, it is much more detrimental in terms of cost, productivity, and quality compared to running even a monolithic application. In this section of the webinar, and we'll also cover the best practices and considerations in microservices execution approach. From our experience, we have noticed that the following areas are the major trouble sources while executing microservices-based projects. We will further discuss in the coming slides on how to avoid these pitfalls, but let's elaborate what these pitfalls are initially. Lack of clear release plans. The way the software is released is very different in microservices as compared to a monolithic. Monolithic deals with releasing mostly a single piece of software and aligning a single team's goal. Typically, any major feature release in microservices world encompasses multiple microservices, and lack of common goal and process to align them will lead to major issues both from productivity and quality. The second important factor is the lack of governance model. The best thing about microservices is the ability for the teams to operate independently. While that is required, there needs to be a base governance mechanism and quality standards that are set cutting across all the microservices. Lack of this leads to unanticipated cost overruns as well as quality inconsistencies. There are also cases where this leads to lack of trust between different microservices, which is sometimes reflected back as poor quality. We have seen cases in our experiences where few microservice teams have had hesitations on calling particular microservice as they do not trust them. This has even led to improper design in the aim of avoiding the calls to these microservices. This situation needs to be curtailed at any cost, and hence a standard governance model needs to be in place right from day one. Lack of right mix of skill set. In a monolithic application, typically there would be multiple teams from operating, and they would majorly work independently. This model works well for monolithic application, but then when you define a microservices team, It is preferred for the team to be well-rounded and self-adequate. Lack of this model leads to unwanted wait times, confusions, race conditions, etc., etc. We'll touch upon the different skill sets that are mandatorily required for a microservices team in the coming slides. Lack of ease and standard collaborative mechanism. Typically, the number of microservices for a decent-sized product or application easily span more than 150. It is hence impossible to have informal collaboration mechanisms between the microservices. A lack of proper established collaboration tool and process will lead to relevant information about a microservice not reaching the other microservices, the learning on each microservice being lost, and hardship of a new team being able to start working on the microservice. Lack of automation process. Whatever is done once in a monolithic application needs to be repeated for multiple microservices. As I stated earlier, the number of microservices we are talking about are minimally 150 plus. Hence, the magnitude of effort and any errors that's caused by humans are increased in very high proportion in a microservices environment. Now, there are cases where organizations have not built the automation upfront and wait for this to be addressed down the line. This is a bad strategy, and this will lead to very high productivity loss and will lead to high amount of rework. Hence, it is important to build automation right from the very first sprint. Now, improper and inadequate test strategies. Lack of proper testing strategy is one of the top 5 fundamental mistakes that organizations commit. The most important benefit of microservice itself is the ability to be developed and released independently. In order to do that, we need to devise proper depths and levels of testing spanning different aspects of microservices. Many cover only end-to-end testing or unit testing in depth and do not pay attention to other forms of testing. Now, this leads to delay in the release and multiple rounds of testing cycles. We'll discuss further in the later slides on what are the different testing mechanisms that we need to devise for microservices. Now that we have discussed the areas to consider and the common pitfalls in microservices execution, I'll walk through the best practices to mitigate the same. Now, coming to release plan, now the product or application needs to be conceptualized just for monolithic apps. That's the starting point, right? Now, the epics are then broken down to stories and are distributed under various microservices. Now, each microservice should be executed with its own sprint board where the respective stories of the microservices are managed, and this is a very important need of microservices. Major and minor release plan for the applications are then usually mapped to the epics, and respective stories of the microservices sprints are tagged against that release. For example, there could be releases, say ABC, and then each of your user stories needs to be tagged against them. Now, the entire release plan for the microservices are then managed and tracked against this release goal. As stated, each microservice team works on the prioritized items in their own board. But some use cases need orchestration across multiple microservices, and this is what we call as a saga team. From our experience, we advocate mini dynamic teams mobilized with their own sprint boards for such integrations between microservices. And this team's major responsibility would be to set up the orchestrations required between many microservices or various microservices for their respective use cases. Now, release plan for the Saga team is also clubbed with the overarching release goal. Now, periodic audits are mandatory to be conducted per release to ensure that all the microservices are adhering to prescribed guidelines. So with this in mind, if you look at the team structure, at any point in time, one can expect at least 10 plus microservices team to be executing parallelly, right? It is hence important to have an overarching Scrum of Scrum team whose goal is to set quality standards, cost control mechanisms and measures, and delivery requirements of the microservices. This team also sets the base for establishing common KPIs for the microservices, metrics for tracking the same, and the strategy to provide visibility across the board. The Scrum of Scrum team also tracks the overall release goal of the application or the product spanning multiple microservices. As stated earlier, the microservices team needs to be well-rounded and encompass the required skill set. Bare minimal skill set required for a microservices team would be development, DevOps, infra or cloud skills, end-to-end automation testing skills, API test skills, and all the other test automation skills that we would be looking in a while. Now, some of these skill sets need not be 100% dedicated, but depending on the need, you can allocate the right percentage. An ideal microservice team is typically around 8 to 10. Moving on to the testing strategy needs to be different for a microservice application, right? A microservice should not rely on manual testing, and that should be the golden rule. Since the microservices are smaller in scope, the time required for this automation testing is generally small and should be kept simple. Automation testing is the major factor in driving a faster release to market, and a microservice success without automation is not possible at all. The type of automated tests that each microservice should develop are unit tests, API tests, event-driven integration tests, Sargo automation tests, contract tests, and end-to-end tests. Now, like any other application, these tests also should follow a pyramid with the highest number of tests being unit tests and the lowest number of tests being the end-to-end tests. Moving on to collaboration, setting up the right collaboration process and tool among the microservices is one of the mandatory steps one should take earlier in the process. Microservices most often depend on each other. As microservices grow, beyond a certain point there would be no visibility on the dependency graph, and this makes making any change extremely difficult. There needs to be a central source of truth which can be referred by anybody on the dependencies between the microservices. It's also advisable to set up notifications to track any upcoming changes or breaking changes automated to the dependent microservices. There also needs to be a central source of truth about microservices functionality, such as its API documentation, messages it publishes, its domain details, etc., etc. It is important for these details so that anybody can understand the details of microservices right from the collaboration tool. A central collab space needs to be in place where different microservices can register their learning, and this is a very important aspect, as every team would repeat the same mistake done by the other teams, leading to huge productivity loss. The last point is on automation. 3 levels of automations need to be in place minimally for microservices, which are infra automation, release automation, and test automation. Provisioning of infrastructure is done using IAC. IAC stands for infrastructure as a code, where the entire provisioning is version controlled and maintained as code. It is recommended to use engines like Terraform, CloudFormation, or ARM templates, which would enable the provisioning in both on-premise. Terraform would help in provisioning on-premise, and the others would help provisioning in the cloud environments respectively. Now, CI and also CD needs to be automated. It is important to automate continuous integration, delivery, and also deployment. And again, CI/CD is usually managed as pipeline as a code. It's very crucial that this is again version controlled and properly maintained in its own repository. It has also become a common practice to adopt containers for microservices deployment, which makes it even more easier for enabling CI/CD process. The other major deployment model for microservices is again serverless, which also enables automation of infrastructure and CI/CD more easier. Now that we have seen the execution best practices, I'll hand it over to Mauli, who will cover the technical pitfalls and their best practices in microservices.
Thanks, Jyoti. So let's start by looking at the technical pitfalls. Based on our experience, these are the major pitfalls that we have often seen in any microservice-based implementation. The first is lack of clear microservice boundary, then lack of base standards for microservices, lack of a well-defined communication pattern between the microservices, and lack of defined DevOps tools and automation, lack of dependency management between microservices, and then oversharing between microservices. We will quickly look at each and every item in this. This is the most significant pitfall that we have often seen, that if not addressed, if this is not done right, I think every other thing just falls, right? So lack of clear microservices boundary is something that is definitely has to be addressed right from the beginning, because there are three major things that happen in terms of missing, or like in terms of not having a clear microservices boundary. The first one is even missing a vital boundary definition. The second one is giving a wrong boundary definition, and then the third one is kind of a result of these, which results in like messy integration databases. So what do we mean by missing boundary definition versus wrong boundary definition? Sometimes it is possible that developers or the designers, due to either their inexperience or due to time crunch or for various reasons, just get into implementing a microservice without even giving a thought to where the boundary should reside, and not figuring out based on the domain model. So the key word here is the domain model and not any other concern, right? So based on that, a boundary definition has to be done, but without that, sometimes if the developers start developing microservices, there is no point even in calling it a microservice. The second one is the wrong boundary definition. For example, if there are two different domain entities or domain models which could be candidates, choosing a wrong one as a boundary between the microservices could also result in a very brittle implementation. And then naturally, people tend to ultimately resort to a messy database-based integration to solve this issue, and unfortunately, it actually gives more problems than actually solving them, right? So this first item, which is lack of clear microservices boundary, is very important to address right from the start of the project. So the next one is lack of base standards for microservices. Standards obviously is important even in monolith-based application, but then for microservices it is even more important. So what the lack of standards leads to in microservices-based implementation, it impacts scalability, security, reliability, maintainability, performance, as well as your fault tolerance, right? If the microservices are not well defined, I mean like the standards, the architecture and design standards are not well defined, there won't be the right level of granularity in how many microservices should be there and what they should be, and that ultimately starts affecting right from your scalability and then maintainability. These are the first two items that take a hit and then continued by every other concern there. So naturally you won't get the benefits of even going for a microservices based development. It also results in more spaghetti code. So the next item of defined, one of the major differences between a monolith based application as well as and microservices is how the services or modules themselves communicate, right? In a monolith, what we call as modules communicate between themselves in various ways, which might or might not be the right way, but then in microservices, it is very important to define a clear-cut communication pattern that adheres to microservice standard. The most important thing, for example, is to not have a typical RPC type calls that used to be done in earlier days, right? So have a clear-cut standard of REST or SOAP calls, and then also have the right level of publishing them, and then with the WSDL. So that is one example of having a communication between the services, but the other one could also be based on messaging. We will look at those things in detail, but then lack of such a communication standard means that there is no clearly defined message structure, and then when you have no uniform communication standard, ultimately that also results in resorting to accessing the database, which is a big no when it comes to microservices. The next one is lack of defined DevOps tools and automation. So what kind of tools and automation that we are looking at here? Containerization and container orchestration, build, deployment, and then CI/CD pipeline that puts these things together. And in terms of automation, it is automated code deployment, automated infrastructure provisioning, and then automated scaling. All these three areas have to be automated. And move on. So the fourth one is a lack of dependency management between the microservices. So there are three areas in which the dependency management might go for a toss, right? From the services themselves calling these services, that is the inter-process communication, and then the second one is the API versions calling the wrong version when it shouldn't have been called, and then the third one is messaging channels. What kind of messages are available and what is the right message to be published or consumed, and those details, right? How that affects the dependency. So what is the solution for these? We will come to that at a later point of this presentation. The next one is oversharing between microservices. So oversharing happens through either a lack of a stringent boundary definition that we saw at the beginning, and then sometimes when people get to share the database, even their oversharing happens naturally. And then when there is a badly designed inter-process communication, that means that the services are highly coupled and they are not loosely coupled. Even there is oversharing happening, right? So that results in making the services very brittle, and also it results in maintenance hell. So what are the various architectural best practices that one could follow in order to avoid the various pitfalls that we saw earlier? That is what we will be looking at this section. So the major areas of the architectural best practices are boundary definition, sharing, data integrity across microservices, infrastructure management, dependency management, API management, message channel. So these are the major areas of architectural best practices, the details of which we will look at in each and every slide going forward. Let's start with boundary definition. So the microservices must be broken down by the domain boundaries. As we saw earlier, it is very important to keep the domain in mind, have the right kind of domain objects as the boundaries, and then define your aggregates and entities to identify the microservices and then the responsibilities. So if you attended one of the early sessions, and this fictional company, a tours and travels company, let's take the same example where there is an order placed for a particular tour, and then there is a separate tour service, and then the payment has to be made by the customer in order to participate in the tour. So how do you identify the boundaries here? At a very simple level, we can say that for an order of a tour, the tour itself is the boundary between order service and the tour service. And then once an order is placed, the payment has to be done, and for that order is the boundary between your order service and payment service. So this is just an example of how one could define a boundary. It is a very involved topic which could take a presentation on its own, but this is just to give you a glimpse of it. So the second important architectural best practice is sharing. What we mean here is do not share. Okay, so do not share code or database between the microservices, and reusable assets need to be independently managed, and that should use patterns such as sidecars. And then polyglot, that is having multiple technologies, particularly in the persistence space, is an accepted and preferred way to build the microservices. And definitely one should consider going polyglot, either in the runtimes or even in the database side. So you can see that you should definitely avoid using a shared database, as you could see in the diagram below. Not only just the shared database, even any domain logic shared library should also be avoided. Usually shared libraries that are actually of some system concerns or some concern that is not directly related to your domain might be acceptable, but that is again subjective and should be well thought through. So the next architectural best practice is data integrity across microservices. Data integrity is a typical challenge that we face in any kind of application, not just microservices, any application that is of a significant size. So how do we make sure that the transactions are happening in a consistent manner, the integrity of the data is maintained? So to do that, microservices has this pattern called Saga, and that once that is implemented, you could have a successful, I would say, a successful implementation of data integrity across your services. So what you see just below is an example of that, how a successfully executed transaction flows and then how a failed transaction flows. So there is an order service, and then the next one is a payment. So once the payment is done, you go for a hotel booking, and then once that is done, you go for a flight booking. The order might be, again, this is just a fictional example, but then if it is a failed transaction, you start again with an order service, but then the moment the payment service fails, it actually has to make sure that give a notification to the Saga orchestrator, and then any service that was executed before that will make sure to revert whatever that it has applied earlier. So this is what Saga pattern is, and it is very important to follow this to maintain data integrity across your microservices. The next one is infra management. So you should automate the entire infrastructure provisioning and DevOps. As Jyoti was mentioning earlier, there are various tools for that, and one should adopt containerization and or a serverless model, and distributed tracing is also very important when it comes to microservices, because it is very difficult usually to debug if something goes wrong in the execution cycle. So having a good distributed tracing tool will help a lot. And then monitoring at an infra level, at a container level, and as well as an application level is very important. So the tools that you see below are just a few examples. For infra provisioning, you have CloudFormation, you have Azure Automation, you have Google Cloud Deployment Manager or Terraform. For containerization, the classic tools like Docker and Kubernetes. And for serverless, you have AWS Lambda or Azure Functions or Google Cloud Functions. For distributed tracing, again, you have Jaeger, Zipkin, New Relics distributed tracking feature, and then the Spring Cloud Sloth. And then monitoring, you have Datadog, Rayman, Prometheus, and Grafana. Almost all these tools that you see are open source, free and open source tools. So there is no excuse not to use these tools in your microservices projects. So the next architectural best practice is dependency management. We saw what could go wrong what generally goes wrong when in terms of dependencies, right? So how do you address that? Automate the publishing of dependency. That is the best solution. Have a centralized source of truth on dependencies between microservices. So if the services themselves are not discoverable, you don't know what service has to be called and how it is to be called, and if you are calling a published API, which version of the API has to be called, and then if you are following a messaging based integration, how that messaging integration should happen, or what kind of messages are there to either like publish or consume, and these are the three major dimensions, and it is important to automate the publishing of these dependencies as and when you build them, and then have a centralized source of truth so that it's easy for the teams to refer that and then implement it accordingly. So API management, that is the next architectural best practice. So having a centralized control on authentication in your API is important, and then also having a centralized control on throttling and publishing of APIs, and exposing a unified set of APIs for the end consumer. So this is usually accomplished through the famous pattern called API gateway that is now almost de facto in any microservices. So the client actually calls this API gateway, which is usually present to the public subnet, say on a cloud or even in your on-premise. This API gateway makes sure the authentication and authorization is done, throttling of the request response is done, and then even to some extent there are API gateways that also take care of SSL termination. There are major benefits that an API gateway has, which you could accomplish at that level even before reaching the microservices. So once that API gateway takes care of these things, in conjunction with an auth server that is available as part of your public subnet, the microservice itself can just focus on the domain logic then, which is in your private subnet. It also in a way helps in maintaining better security. So the next architectural best practice is a message channel. Okay, so we looked at the integration. So message channel is one of the most important features of integration in a microservices based application. So you follow a defined message communication pattern between microservices, and also have a central messaging tool or platform like Kafka, right? And how do you determine what is the right kind of messaging pattern that one could choose? So there are two broad dimensions to it. One in terms of the relationship, whether it is one-to-one or one-to-many. The next in terms of how the response is received, either it is synchronous or asynchronous. So you could see here, this is the classic table that is usually given by engineers. But this acts as an important indicator of what kind of messaging pattern could be chosen for your needs. So if you say you have a very synchronous API, and then you also have one specific endpoint which has to give that response immediately, you go for a request and response. But you know that it need not be returned immediately, but at the same time I might have multiple consumers who are interested in receiving the message. You could go for a publish subscribe model. So this is just a comprehensive table of all the messaging patterns, the ones that you could choose from based on your needs. Right, so that brings us to the best practices that you could follow to avoid those pitfalls. Okay, I now hand it over back to Anusha.
Before we can actually end the webinar, we have a few questions, Mauli, from our viewers. So one of our viewers has asked us the question, for better dependency graphs, why not use distributed tracing?
Yeah. So distributed tracing, as Mauli discussed, is a very important part of monitoring, right? But that's more runtime, and that's aftermath, right? And then the dependency graph, there are two perspectives. One, during runtime, you discover what the dependencies are, and then to track between what is executed and what is the time taken between different calls, and that's where distributed tracking would help you, tracing would help you. Now there is another aspect of it from a development perspective, right? So when developers and the design team is consuming, say, an API, right? And if there is a need for that particular API that is being developed by some other microservices team to change in version, right? So there is no way that it is going to know that so and so consumers are calling these APIs, and there is going to be a adverse effort on it. I mean, you could follow a strategy that you are always backward compatible, but it is often not possible in reality, right? You are going to be sunsetting certain versions after a and similarly, just not API calls, it also boils back to your message channels. Let's say there is a pub/sub mechanism, and then you are establishing a message or you're publishing a message to, say, Kafka, and there are consumers to it. You're also supposed to maintain the contract and backward compatibility, right? But again, you need to know whom the consumers of messages are, and more importantly, if there are upcoming changes that are coming, and even if that is not going to affect the version, the consumers are supposed to know, and anybody interested in the microservice are supposed to know, and that's what we mean by the dependency graph. So you're right, distributed tracing is required, and in runtime it would help you to troubleshoot and then give you the indication of performance and so on. In development time as well, you need to look at tools to track the dependencies and automate the notifications of changes and so on.
Great, thank you, Jyoti. So we have another question. What does messy database integration mean, and any example or use case that you can give us?
Yeah. So this has more to do with, I would say, in earlier days with monolith-based applications, and that is one of the reasons why people go for microservices. So messy database integration means that most of the times the business logic is usually mixed up in the code, and then different modules access the database to share the logic. For example, if there is an order and there is a, say, a credit, or there is a reward point or whatnot, right? Any such additional features that you want to integrate, usually in earlier days were not separated as different microservices. But what happens is that the monolith used to just write them as modules, but then keep using the database tables themselves for the integration. What this results in different set of developers who are part of the same monolith application writing the implementations in different manner, and that is what we really mean by messy integration in database. So how do you avoid that? The moment you go for microservices, you have well-defined boundaries, you have teams who know what to do clearly, because they cannot just go touch the databases which is not under their purview, and that is how this messy database problem is solved.
Just to add one more point to what Maury said. So one of the points that we discussed is sharing the database should be at any cost avoided in microservices, right? Sometimes as an anti-pattern, people tend to make the mistake of integrating microservices through database, and that's a big anti-pattern like we discussed, and we need to ensure that that's never taken into account. There can be only two ways to integrate, one using API, the other one is using message channels, right? And you also need to make a note that different databases can be different technologies as well. So some could be on NoSQL, some could be on RDBMS, and it's completely relevant in microservices scenario, and hence any implementation details of the other microservices you are not supposed to depend on.
Okay, great. Thank you so much, Jyoti and Chandramouli, for your insights. I'm sure our listeners found this session very helpful. I hope this webinar helps our viewers get a step closer to successfully migrating to microservices. Before we finish, I would like to quickly go over our Aspire systems capabilities. We are an end-to-end technology services firm catering to clients from startups to Fortune 1000 companies. At the moment, we have over 150 active customers and over 3,000 employees. Our areas of expertise include software engineering, testing, digital services, and infrastructure and application support. Our vertical focus extends to ISVs, the retail sector, and banking and financial services. We are located globally, offshore, onshore, and nearshore, with a nearshore presence in India, USA, Poland, Mexico, United Kingdom, UAE, and Singapore. That's all I have for tonight. Do follow us on LinkedIn and get updates on our future webinars. Have a good rest of the day or a good night if you live here in India. For now, this is Anusha Natarajan signing off.